All right, so one of the questions you might be thinking about is why carbon? Why is all life based on carbon? And that's because carbon has these special properties that other elements simply don't. So in general, carbon forms 4 bonds, and this allows it to make chains, and very relatively stable chains. Remember, carbon cannot break the octet rule, so it can't have more than 4 bonds. 4 bonds is the max. Never draw carbon with more than 4 bonds. So an example of a chain, here we just have 1 carbon with all H's, right? This is methane, and then you could extend it to 2 carbons with all hydrogens attached, and go on and so forth. And then you could even branch carbons, right? Something like that. And then, just add the rest H's. So it can form these chains and these branched chains. Carbon can also make double and triple bonds with itself and other elements. So here's just an example of a carbon-carbon double bond, and then a carbon-carbon triple bond. And so this ability to form these chains, these branch chains, and then these double and single bonds make carbon highly modular. And so what that means is that we can, it's basically all just made out of little pieces that we can mix and match and recombine to make all kinds of different compounds. There's practically an infinite amount of compounds you can make with just carbon and hydrogen. In addition to these bonding properties, carbon is kind of in this Goldilocks zone of chemical reactivity. And so what I mean by that is that it's reactive enough to change, right? We can take some compound of carbon and make it to something else, but at the same time, it's stable enough to exist for a while. So as soon as you make some kind of new product, it doesn't just fall apart instantly. So let's take a look at an example of that. So we can take this guy right here, this double bound 2 carbon chain. This is ethene. You don't have to know that. And it's a colorless gas. And it's also a plant hormone. What helps your bananas ripen. And so if we took this compound and then we threw it in some acid and some water, it would react and it would form ethanol. This compound right here. So ethane can turn into ethanol. And so this is the alcohol that you drink, right? This is what's found in your liquor, beer, wine, that kind of stuff. And then if we took this alcohol and we further reacted it with some acid and an oxidant such as potassium permanganate, we could turn it into this compound right here. And so this might look familiar. This is acetic acid, which is essentially just vinegar. And then if we reacted this further with some more acid and then maybe added some isoamyl alcohol, which looks something like this. I won't draw some of the lone pairs and whatnot. We could form what's known as isoamyl acetate, which looks like this. And so this is what gives bananas their smell. And is used as an artificial, smelling agent to make a lot of things smell nice. So that shows you kind of the modularity and the stability of carbon-based compounds, right? We can take ethene, a colorless gas, and a plant hormone, something that can exist perfectly fine. But if we put it in some acid and some water, we can turn it into ethanol, which is the alcohol that you can drink, which is obviously stable enough to store on the shelf and whatnot. If we added some acid and some permanganate, we could turn it into vinegar, which again is stable enough to exist because you have vinegar in your household probably. And then you could react it with some other compounds to make something completely different, right? Isoamyl acetate, which is what gives bananas their smells and is stable enough to exist as well. So as you can see, carbon is highly modular. It's just reactive enough to allow us to do stuff with it, but not too reactive that when we make something new that it falls apart.